Hi everyone, and welcome to a new episode of the Allplane Podcast, where we talk with the movers and shakers redefining the future of commercial aviation. And before we dive into today's conversation, I would like to remind you that all previous episodes of this podcast, along with many other interesting stories about innovation and sustainability in aviation, are available on the Allplane website at allplane.tv, Allplane.tv. I would also like to invite you to subscribe to our newsletter, which focuses on sustainability in the aviation industry. You can find the subscription link right on our website. And now let's get into today's episode, which I am sure you're going to enjoy because our guest today, David Valaer, is a very interesting and articulate entrepreneur who is working on an idea that sounds quite straightforward in principle, and yet, if finally implemented, has the potential to save airlines tons of fuel and emissions. Originally from the US Pacific Northwest, David has spent most of his life surrounded by planes. He was a fighter pilot in the US Air Force flying F-16s, and he then went on to acquire and grow a successful business in the aerial firefighting technology space, which he ended up selling. And now, more recently, he's turned his attention, his entrepreneurial energy, to solving the problem of fuel consumption and emissions when aircraft are taxiing through airports. Because did you know that taxiing can account for somewhere between 5 and 15% approximately of the fuel consumption of an aircraft? This varies, of course, by type of aircraft and the length of stage, but to give you a point of reference, for certain types of aircraft and operators, we might be talking about $300,000 per year and per aircraft, so quite a lot of money. And this is because aircraft often use their engines to move around on the ground, which is a massive waste of resources. David's latest venture tries to solve this by electrifying the taxiing of aircraft while at the airport. Hence the name, Green Taxi. How does David plan to do it, and which technologies does Green Taxi plan to use to basically pick up the low-hanging fruit that are these ground emissions? I think it's best if we hear it all directly from David. So now, without further ado, let me welcome him to the podcast. Hi David, how are you?
Good, Miguel.
Good to see you again. We have been able to coincide quite a few times this quarter at multiple events, and that's why I thought it was really interesting to have you here on the podcast to talk about Green Taxi, which is a really interesting and promising technology that you have developed. But first of all, like every other guest in the podcast, I would like you to introduce yourself, because you've got a pretty interesting story in aerospace. You've been in the Air Force, you've been an entrepreneur. Before starting Green Taxi, you already had a successful venture that you sold. Tell us a bit more about yourself, and then we can maybe talk about Green Taxi.
I appreciate that, Miguel. Yeah, and I appreciate our time in Barcelona and all of our various events we've gone to together. So looking forward to doing more of those together for sure. I'm David Valaer, founder and CEO of Green Taxi Aerospace. I've been very fortunate and blessed in the aerospace industry. I learned to fly when I was 15 years old. In fact, my father would buy a Cessna 185 on floats every summer, and we'd explore Alaska. So I grew up in Alaska in the summers, flying float planes around with him as a young boy.
Wow, that's quite a unique type of experience. I mean, I don't think many people can say that, who are spending the holidays like flying on a float plane in Alaska. That's amazing.
It was back then. A Cessna 185 was $36,000 new. And we'd buy a brand new one and fly it to Alaska and sell it at the end of the summer and make a profit. So my dad, I learned some of my entrepreneurship from my father. He was an entrepreneur and a wheat farmer at a place called Walla, Washington. That's where I'm from. And we'd fish and hunt around the state of Alaska. In fact, the picture in the background right there is my flying next to Mount McKinley at 16,000 feet in my Bonanza here about 3 years ago. So still very passionate about aviation for sure. Like I say, got my private license when I was 16. And then really, in fact, my dad wanted me to fly the airplane every day after school. It was a very good way to get yourself out of some negative high school situations. I'd fly back and forth to see my girlfriend in Canada. But he goes to check the fuel pump one day, and 1,000 gallons of aircraft fuel has been burned, me flying back and forth to see my girlfriend. So I got my wings clipped that day. I didn't get to fly back and forth to see my girlfriend anymore after that.
Wow, that's quite a story. And then you joined the Air Force, right? So you were flying
I did.
F-16s.
Well, yeah, a few other things I was very blessed to do. So I got an opportunity to fly float planes in Alaska. I was a bush pilot, so I was a salmon spotter. So I'd fly out to the middle of the ocean and find the salmon for the commercial fishing fleet. So you see the show Dangerous Catch. Well, think about flying in some of those conditions in the middle of the ocean in a some Super Cub, sometimes 185s on floats, and being 80 miles or 100 miles offshore. It was a very exciting job, but not a risk-free job for sure.
So
Very, very enjoyable.
you were spotting the fish from the air,
Correct.
as if
Yeah,
you were in a maritime patrol aircraft, but just
uh,
not submarine, not hunting for submarines, but for for
for
fish.
finding the fish. Finding the fish is called
Wow,
salmon spotting. Yep, yep.
wow.
Uh, so did that for several summers until the Exxon Valdez oil spill in '89. Uh, so I got my MBA in finance at University of Texas at Austin and had my first job at PricewaterhouseCoopers doing mergers and acquisitions here in Dallas, Texas. And I got my, I guess you can call it maybe an early midlife crisis. I don't consider it that, but at 25 years old, I applied for the Air Force and also 40 Air National Guard units. And make a long story short, approximately of the 20,000 people that apply, one person actually makes it through the whole process to get a slot. And I got a slot and was able to fly A-7Ds, which is an attack jet, a Navy attack jet, uh, and then converted over to F-16s and flew F-16C models, Block 30 F-16s. So yeah, I went from having a couple thousand hours of civilian time and got to go through the Air Force fighter pilot training. So yes, an incredible opportunity with the Iowa Air National Guard. Very, very enjoyable.
And then I think you went back to, let's say, amphibious aviation, right? I mean, you created a company that made these sort of containers that firefighting helicopters carry to fight wildfires.
Correct.
Mhm.
Yeah, it was I was in the Air Force and I knew I wanted to have the opportunity to find an older gentleman that needed somebody trustworthy and qualified to take their business over. So I was very fortunate to meet a man in Portland, Oregon. He had a company called Simplex Aerospace. And Simplex at that point in time would made spray systems that sprayed crops with helicopters. And
Mhm.
they were just getting into the firefighting market. Helicopter firefighting really wasn't a major thing at that point in time. And over the course of several years, I was able to be part of the certification, development certification, and I owned the company 100%. And we certified approximately 20 to 25 new systems for everything from the Bell 212, 412, UH-1H, Augusta, AS-350, Aerospace EL, and even the Sky Crane helicopters. So yeah, we sold those worldwide and LA City Fire Department and Tokyo Fire Department and grew that company about 10 times the size it was when I bought it. So it was, an incredible opportunity to take my passion for aviation, but then my business passion, entrepreneur passion, and really see it take off literally and figuratively. And actually, I got my commercial helicopter ratings along the way. So I'm a commercially rated helicopter pilot, got to fly on some forest fire work.
And at what point did you decide that it was time to create what has become Green Taxi?
So when I was working with Simplex Aerospace, a consultant, Phil Moylan, he consulted for various aerospace companies as a marketing consultant. And he started to go working for a company that was developing a electric taxi. And he said, David, this is a very interesting technology. And I said, wow, let me look at that. Long story short, I did not invest in that company. That was back in 2011 timeframe. But I became very interested in the concept. And I've done several other companies since Simplex. Uh, and in early 2020, I was at the Experimental Aircraft Association Oshkosh show, and a man named Tom Johnson had written a book on electric taxi, and he was selling them at Oshkosh. And I laughed. I said, "Oh my goodness, I looked at this 10 years ago and I was so surprised that no one had ever done it, kind of completed it." So it re-sparked in me an interest to openly, I will be very open to, initially was to disprove or prove that this would not work. Because it made so much sense to save up to around 100,000 gallons of fuel per year per aircraft. As I did the numbers, and I'll get to this later on, but 5% to 20% of the fuel for the whole airliner flight is burned on the ground during taxi operations.
One
And it's
one
like,
second. I think it's a good moment here to just stop 1 second because I guess many people in the audience are familiar with the concept of taxing, but I just wanted to make sure that everyone got the concept. So you are looking at the technology that prevents aircraft from burning fuel while they are moving on the ground. So I think we can look at some numbers now in a second, but basically when an aircraft is moving through an airport, it's burning fuel as it moves, as it was just like as a car, basically. This is moving, it's rolling on the tarmac, right?
correct. Yeah, let me unpack that that's a great segue. Let's unpack this for a second. Right now, the way an airliner moves is they use their main jet engines. Those engines are made to be used in flight. They're not designed and optimized for ground operation. And they have excessive power for the ground operations. So it'd be like driving your car with the gas pedal 3/4 of the way down on the floor. You're burning way more fuel than you need to do the job. So as a result, as a jet pilot, I'm always dragging my brakes and applying my brakes over and over again because I've got too much fuel being used during the ground operations. But it's the way it's always been done. Everyone's always used their main jet engines to taxi.
What about these vehicles, the ground equipment? There are some these mototogs and these sort of vehicles that can move the aircraft. I guess they are not always used and they cannot be used at all times and in all places, right?
Correct. There's a company, Robotug, that it's obviously we all know that as an aircraft gets pushed away from the terminal, there's a tug that pushes the airplane on the ground. So you could use that same tug to drag the airplane all the way out to the runway, which by the way was done in the 80s with 747 aircraft at LaGuardia. And it works quite fine. The challenge is if you have a separate vehicle that takes the airplane out to the end of the runway, now you've got a taxi bot. It's going to be Taxi Bot's the name of the company. They've got a great idea, but now you've got the complexities of getting the taxi bot tug all the way back through all the airplanes. You got to have how many do you own? You can only use one per aircraft. And then you've got to cycle them through. Who owns them? Does the airport own them? Does the airline own them? It hasn't getting as much traction as I think they thought it would. So what we do differently is we mount the electric motor system on the aircraft, and it stays with the aircraft the whole time on the main landing gear. And what it does, very simply, is it takes the energy, the power, electrical power from the auxiliary power unit. It's called the APU. It's in the tail of the airplane. And we take that power to drive an electric motor that's mounted on the main landing gear to allow the aircraft to move forward and back, taxi, without its main engines. No batteries. That's something that people always ask me, is there batteries? There's no batteries, but use the existing power. It weighs under 300 pounds and it stays with the airplane the whole time. And anyway, that's the major concept of what electric taxi or e-taxi is that Safran did, this other company did, and that now we're bringing to the forefront as a certified product.
And what is driving this APU? What is powering it?
Yep, it's a jet engine. It's a, for example, on the Embraer, it's a Pratt and Whitney small engine. But the difference is you're burning about a tenth, 10% of the fuel flow that the main jet engines use or the APU. So is it zero emissions? No, it's not zero emissions. It's 90% less emissions than a main jet engine is, but it's not, it uses a small jet engine, turbine engine that drives a generator in the tail that provides us the electrical power to move the aircraft with the electric motor.
Okay, so then you became intrigued by this concept of the electric taxing. Is then when you set up Green Taxi. When was that? And what's been the, let's say, the path that you follow since then? Because I think you were talking about 2011, around that time. So you've been working in this concept for quite some time, isn't it?
Well, 2011, 2012 is when Safran did their demonstration at the Paris Air Show, which I was not part of. I didn't even know it occurred until later on. 2021 is when I really got engaged and intrigued to re-enter this marketplace. And the first thing I did is I looked at what's the intellectual property. Because if there's a super strong patent that keeps us from certifying or getting the system, well, that's a problem. And yes, Boeing aircraft has a very extensive patent, stem to stern, on the system. Long story short, I got in touch with Boeing. I was able to work out a situation so we're able to use that patent for our system. So we don't have any patent infringement issues. And Boeing obviously looked at this. They spent millions of dollars developing a patent. So with that piece in place, and this would have been 2022, 2023 timeframe, and now at this point in time, I'm still funding it 100% from my family office money from my sale of Simplex Aerospace, and really doing the research work, not the development work at that point in time. So in 2024, actually at Sustainable Aviation Futures, the SAF event in Houston, Texas, which you may have attended along the way, Miguel. I think you
I
have.
haven't, but I'm familiar with it. Yeah.
Yep. Someone mentioned to me about how the FAA had an FAST grant for sustainable aviation emissions and fuel savings. Like, wow, that'd be perfect for us. So I spent 2 full months with a grant writing team and worked very hard, 140-page application in 2024, excuse me, in 2023, late 2023. And in summer of 2024, I was amazed and incredibly pleased that we were selected by the FAA for a $5.6 million FAST grant to help us fund our development of the e-taxi for the Embraer 175. So that was obviously an incredible validation and financial benefit. Along the way, we've been talking to Delta Airlines, and Delta Airlines is a very out in front company in terms of sustainability and really being a very progressive company that way.
Yeah,
And
actually, we had Amelia De Luca, the Chief Sustainability Officer of Delta Airlines, was a guest of this podcast earlier
yeah,
this year. I
and
will
they've
add a
been
link to the show notes so that people can check that out as well.
That'd be great. Yeah, because I mean, between Emily and Sangeeta and many of the other team members at Delta Airlines, they've been incredibly supportive. And we are now a partner with them. We've done several press releases and meet with them pretty much once every few weeks. They're also providing us with technical support and documentation on the aircraft, which has been hugely helpful. In fact, something we'll have for you later on, Miguel, is we're doing a deep dive on every granular benefit, foreign object damage savings, the savings from the pushback by the tug, the latency savings, all these things that e-taxi does. So e-taxi saves so much more than just fuel and emissions, which obviously is the number one of the list, but there's a lot more benefits as well.
Yeah, actually, I would like to do a dive into each of these advantages. But first of all, I would like to um, set the frame a little bit to let people understand how this looks in practice. I mean, is it a device? How is it connected to the aircraft? Guide us a little bit through the, let's say, the hardware part of it.
Mhm. So yeah, let me go through the details. So again, we take the 400 hertz, three-phase, 115-volt AC power from the APU. We rectify it, i.e. convert it to DC, direct current, to then drive the motor electronic module. This then tells the motor how fast to go forward, how fast to go in reverse. There's obviously a small pilot control station with a joystick. So the pilot simply puts the joystick in the back position for reverse, forward for forward It's got an on-off switch. He uses his normal brakes and his normal nose-wheel steering, so minimal pilot training. That was something else that's very important on this. And then there's the electric motor that's mounted between the two main gear tires and attaches to the aircraft, of course, and then has a pinion drive sprocket that then drives the main landing gear wheel.
So this is basically, it's like a little box that you attach to the landing gear.
Yeah, it's a motor and drivetrain and gearbox. Yes, it's a motor and gearbox. One of the most important part of the system is to make sure that it's physically disconnected on takeoff and landing and in flight. The system is not used in flight. It's not used on landing. It's not used on takeoff, of course, because you want to have a physical separation. So that way it's called inert. It's a non-flight module. It's only used on the ground. And people will ask, what about if you land and use it for regenerative energy and help it make the takeoff shorter with making the airplane move faster? Those are theoretical ideas that just from a certification standpoint would make the project dramatically more complicated. So we make sure it's a non-flight component that separates from the aircraft. It stays on the aircraft, but the sprocket connection is disconnected during takeoff and landing. Mm-hmm.
Okay, that's clear then. But you mentioned that, for example, companies like Safran were testing that. Why they didn't go farther with the development and launch their own system to the market in these decades since they were testing it?
Yeah, great question. I met with Safran now 3 or 4 times, including the Future Aviation Festival at Paris Air Show, and we've got a very good relationship. Safran did the system in 2011, 2012, demonstrated it. Lufthansa was looking at buying 100 units per year. Airbus gave a no technical objection for the system. That's not a certification. That's just, it won't hurt the airplane. And one of my employees now, a man named Joe Hoffman, was the president of L3 who did the system with Safran and Airbus. He said, David, this is the most exciting project I've ever worked on my whole aviation career. Couple issues. One, there was some internal politics with Safran between divisions regarding the e-taxi. That was an issue that there's some other backstory on that. 2 was that the fuel prices were much lower back then. So the fuel prices weren't driving the savings. 3 is the push for sustainable aviation and net zero wasn't 2012 was relatively insignificant compared to today. But probably the biggest one is this. Their system weighed over 700 pounds. The motor electronics, the module that controls the motor for their system, was on a pallet and it fit in the cargo bay. It was huge. That was all they had for technology back then. Well, billions of dollars have been spent on hybrid vehicle technology, off-road and F1 race car technology. And we are the benefactor of that because what we're doing is I've spent the full year now, gone to 4 trade shows, had a search firm, helped me find the very best electronics and very best motors that exist in the world. And our systems, theirs weighed over 700 pounds. Ours is going to weigh under 300 pounds. And for an airline, that's a huge differential to save that weight. And also, we don't have the technological risk. The motors are developed, the motor electronics are developed, and they were developing all that back with Safran in those days. Safran and we've had several conversations, and they've made it very, very clear. They believe in e-taxi. They're going to do e-taxi, electric taxi, but only for future fit aircraft, i.e. clean sheet design where they design the landing gear from scratch. So that'll be in the next 20, 30 years before a brand new clean sheet design will come out. We'll have electric taxi. What differentiates us is we're doing the retrofit market. We're putting ours on existing airplanes, which openly from an engineering standpoint is significantly more challenging because now I've got to work around the existing brake systems and modules, tow bar pins. All those areas have got to be considered because I'm modifying the existing airplane, not doing a clean sheet design. So Safran still believes in the concept, but for those reasons, And also, it's harder for large companies to do a more of a niche product like this because it is a retrofit kit for the existing airplane. So that'd be a major aspect.
That this could work potentially with any type of aircraft, any
Correct.
type of airliner.
Correct. Correct.
You mentioned the
So
Embraer 175, I think. Why this aircraft in particular?
great question. So if you have a 787 example only that flies across the pond and flies 9 hours per flight, and let's say it does 2 flights per day, it's only taxiing 1 or 2 times a day, and it's a very short time relative to the long flight time. What you want is an airplane that flies fairly short and has long taxi times multiple times a day, which is what a regional airline does. So the Embraer 175, and this is Delta's data, turns or has 4.5 flights per day. Wow, that means it's taxiing 4.5 times per day and doesn't fly very long flights. The CRJ aircraft, the Bombardier now Mitsubishi Heavy Industries aircraft, it turns about 6 times per day. So this gives the e-taxi more opportunity to benefit the airline financially. Could we do a 787? Yep. Could we do a 777? Yes. Could that be something in the future we do? Yes. But the economic benefits are not as great as it would be on a 737 or a regional jet or let's say a 320neo that's doing shorter flights. That's where the benefits go from the 5% of the fuel upwards of 20% of the fuel is used on ground taxi operations.
Sorry, how much you said?
So Cerium, who you know is a major data
Yes.
analytics company, did an analysis of every single flight for 2024 and to determine what percent of the fuel for the whole flight, for the whole, going from point A to point B is used on the ground. And it ranges from 5% to 20%
20 is
of
a
the,
lot.
that's huge. And it's actually higher than that, but I don't quote the other numbers because I don't want people to wonder
Okay.
about the numbers. But if you look at the detailed sheet that I just got done doing with Delta, they average 27 minutes of taxi time per flight. That's an average. LaGuardia is a lot higher, maybe early in the morning at DFW may be shorter, but it's 27 minutes total taxi time. The flight, in many cases for a regional aircraft, is under an hour. So if you look at that ratio, you quickly go, oh, okay. And a jet engine burns about 60% of the fuel, 50 to 60% of the fuel flow that it has at altitude at idle, because jet engines are not optimized for ground operations. So you've got a very large engine burn a lot of fuel for 27 minutes on the ground. And if you look at the flight times, you'll come up with this 5 to 20% of the fuel. It's about 80 to 100,000 gallons of fuel per year per aircraft for the E175.
And how does this translate into dollars and into carbon emissions?
So if you do the math all the way through, and this, we're actually doing this on behalf of Embraer currently with Delta Airlines, let me go through the various aspects for the cost savings. So first of all is the fuel. So if you assume 80,000 gallons of fuel at $3 a gallon, that's $240,000 per year per aircraft in fuel. If you're single engine versus two engine, there's some differentials there. And people always ask us, what's the cost to carry? How much fuel does it take to carry the unit for a year? Great question. Delta ran the numbers and it takes 4,686 gallons of fuel to carry it for a year.
So that's the extra weight from carrying the system.
Correct. So out of the 80,000 gallons of fuel savings, you have to deduct 4,006. So it's about 5% of the overall savings are used to carry the system because of the extra weight.
Mm-hmm.
That translates to around 1,000 to 1,200 metric tons of CO2 per year per aircraft, which is equivalent to about 200 vehicles. 200 vehicles off the road, it's the same as one aircraft on the ground per year.
You mean vehicles?
So
you mean a regular car?
Regular car.
Okay.
For the whole year.
Mm-hmm.
And this is really important because Amsterdam Airport, as you probably know, is very progressive on their emissions, and they're looking to mandate that you can't taxi with your jet engines starting 2030.
Okay.
We just had a call with California Air Resource Board, CARB, and they're very keen on this as well because the inhabitants around the airport are breathing all the CO2 and carbon monoxide and NOx, let alone the environmental issues. So the airports are pushing very hard for saving of this emissions.
Hmm.
If you were to electrify all the buses, all the tugs, everything on the ground at the airport, which is a good thing for sure, but one aircraft taxiing a year for its normal flight cycle is more emissions than all the buses and all the ground support equipment for the whole airport.
Wow.
So the lowest hanging fruit is electric taxi. It's a huge benefit from an emission standpoint. And then you multiply that by, thousands of aircraft, it's a huge number of emission savings.
And economic benefit as well.
Delta actually gave me an incredible statistic. They said that they value the CO2 and emission savings at $1 per gallon. So we save 80,000 gallons of fuel. That's about $80,000 per year. So now we're up to $320,000 per year of savings per aircraft per year. Then, if you look at something called foreign object damage, where the engines suck up a pop can, a wrench, a rock, whatever, it goes to the jet engine, there's about 1.2 occurrences of this per year just for SkyWest alone. That's worth about $20,000 a year because it costs the airline anywhere from 300,000 for an inspection to a couple million if the engine is trashed because of foreign object damage.
So it's 1.2 occurrences of the foreign debris per
Foreign object
aircraft?
damage.
Per
No,
aircraft.
for the fleet, for the fleet of
For the whole
SkyWest.
fleet.
That's
Okay.
200 aircraft. Yep, yep. So it's not frequent, but when it happens, it's really expensive. So
Okay.
that's another benefit. You use about $20,000 for that. So now we're up to about 340 per year.
Hmm.
Then if you look at the brake savings, remember I mentioned how there's too much thrust from the jet engines. As a jet pilot, I'm dragging my brakes because I've got too much. It's like driving your car with the gas pedal three-quarters of the way down. You're dragging your brakes. It's got too much energy from the aircraft. Well, it's going to double or possibly triple brake life. And that's going to be probably about $20,000 a year plus in savings for that.
Per
So that's
aircraft.
another per aircraft per year. And then if you look at the tug, there's two savings from the tug, not needing a tug, because we can now back away from the terminal without a ground tug between the marshalers and the pilot. The pilot can put the joystick in reverse. The airplane backs up away from the gate. So no tug, saves that cost. But there's also 5 to 7 tug damage incidents for the SkyWest fleet per month.
Per month. Wow.
Per month. Now, sometimes it's only just they overloaded the nose gear and it's just an inspection, not a big deal. But sometimes it's significant damage. That's about $20,000 a year, 15 to 10 to $20,000 per year, because you minimize that damage on the aircraft. Plus, no tug, say the tug operator, no damage to the nose wheel. And then something the airlines are quite keen about is when you back the aircraft up with a tug, then it sits on the tarmac and you have to unhook the tug and unplug from the airplane and start engine number one. And if you two engines start number two, it's 2 to 4 minutes of what they call latency savings of the aircraft sitting in the middle of the ramp, unhooking from the tug. Every cycle, as you well know, airplanes, you save block time, you save turn time.
How do these advantages compare to the cost of installing the system? So, in other words, how fast can airlines recover the investment that they would have to make to install green taxi, to retrofit their fleets to have this system?
So if you look at all the various savings, depending if it's single engine taxi or two engine taxi, there's a lot of different variables you look at. It ranges between $200,000 per year of savings to upwards of $400,000 per year per aircraft savings for the airline. So we've looked at how do we bring this to the most effective way to the airline. Airlines are quite used to leasing equipment. Many of them lease their engines, some of them lease their actual aircraft. And we want to minimize the CapEx and the risk for the airlines. So we're going to lease our systems. It'll be a fixed price lease that we'll work through together. We're working through that with various airlines right now. But bottom line is, here's our customer guarantee that you will, as the airline operator, you'll make a 50% return on your lease payment. So let's use an example. Let's say the lease payment is $200,000 per year. You'll obviously save your $200,000 between these various savings, and you'll save an additional $100,000 on top of that. So you'll save a total of $300,000, and your lease payment would be $200,000. We want the airlines to have a significant rate of return on this, so there's no question about the value of the system. At the same time, by us leasing it, that allows us to make sure it's maintained correctly, and any part support we take care of, all of those, we minimize any complexities for the airline. So that's how we're doing this. System's good for the 20-year life of the aircraft. So the motor really won't need any replacing. We'll take it to depot maintenance every now and then. The sprocket and the gear assembly, we'll have to replace that every now and then. But again, we'll provide that at no charge to the airline as part of our lease payment. And that's been quite well accepted by the airline industry as a leasing model.
Who would install it?
So the system takes about 2 days to install because, again, we're putting on the existing airplane between the various modules and the motor and the gear train, and no major aircraft modification required. Takes about 2 days. We will be on site to work with the airline to install the system. Obviously, their mechanics are going to sign the books and do the paperwork for this. We see this occurring at a B or a C check when the airplane's already coming through for typically an airplane. I was up at the Embraer MRO facility in Nashville, Tennessee, just 2 months ago, and they say that the airplanes are typically there from 5 to 15 days for a phase check, and we'll do it during phase checks, so there'll be no downtime for the airplane for the installation of the system under our supervision with the airline mechanics physically doing the work on the software system.
So now this system is not yet certified. So you obviously would need to get it certified before it can go into market. What is your road to market? Do you have a specific time frame orientative to become certified and for airlines to be able to order it?
So we really want to always under-promise and over-deliver. So I'm trying to always be conservative in my estimates. The FAA gave us that FAST grant. So they evaluated our cert plan and our capabilities, and they gave us a $5.6 million grant. So that's a pretty good vote of confidence. A Standard Aero, who's a $5.6 billion aerospace company, they're leading our certification process, which they would have taken the project as they believed it was certifiable. We just completed our certification plan called a CERT plan, and that has been delivered to the Aircraft Certification Office, the ACO. In 2026, we'll be finalizing the design details and having the physical components produced. Early 2027 is our goal for aircraft ground taxi test operations with the thing called a conforming prototype. Not just a prototype, it's been proven it works. Now it's time to do an FAA approved conforming prototype for our certification with the goal of having the certification done by the end of 2027. And once the certification is done, we can ramp up quite quickly. We can produce, because again, these are existing proven motors, motor electronics, so we can ramp that as quickly as reasonably possible. So we see widespread deployment of this late 2027 and into 28. Initially for the 175, Embraer 175, but the Bombardier CRJ would follow that. Boeing Airlines reached out to us and called us actually about the 737, and the subsequent certifications will take significantly less time because we'll already have a certification plan approved. Many of the components will already be approved, so it'll be a modified cert, not a brand new cert from scratch for a future aircraft after our 2027 initial cert is done.
Hmm. And commercially speaking, are you going to be selling this to the airlines or working through the OEMs so that they can propose that to the airlines? What's your business model, your commercial plan?
Yep, yep. So Embraer and MHARJ and Boeing would all be, we're getting technical data from them, but we do not, our goal initially is not to sell through them. Our goal is to get a thing called a supplemental type certificate, an STC, which allows us to sell directly to the airlines. We would assist in the installation. So we want the OEMs to be on board with the system, or i.e. have some input on it. But in terms of the actual system, we do not require the OEM to be part of that. We would not sell through the OEM. We're building the relationships directly with the SkyWest, Alaska Airlines, Horizon Airlines, Republic Airlines, Envoy, Delta Connection, United Express. Those are the customers we'll be selling directly to for the equipment, not through the OEM.
Hmm. What about the industrial side of it? Are you planning to manufacture this all these components to put together all these systems in a industrial facility or subcontract that? What's the manufacturing plan?
Yeah, so once you have the supplemental type certificate, you have to have them call it a PMA, a Parts Manufacturing Authority. Initially, we will be using Standard Aero out of Illinois to do the PMA. That's the quality control system. It's kind of like ISO 9000, but on steroid because it's the FAA process.
Hmm.
Once we get the initial systems on the aircraft and we're in full scale production, later on we'll probably bring the PMA here to Dallas, Texas, where our company headquarters is at. And what you do then is you take all the components and conform them, make sure they meet type design, build a kit, and we'll put the kits together here in Dallas and then ship them to the various airline locations for installation on the aircraft.
Wow, very interesting. If people wish to learn more about green taxi, what resources would you suggest they can check?
Well, first of all, we've been very fortunate to have over 15 articles written about our company over the last year. So if you just type in Green Taxi Aerospace on your browser, there'll be quite a few different articles come up. Our website, obviously, www.greentaxiaerospace.com is our corporate website that has a lot more details. And on there is our contact information, our info at greentaxiaerospace.com. Reach out to us. We've got a phone number there as well. You can call us, and we'd love to share more of the details of our system with whoever would be interested.
Great. It's just left for me to say, well, thank you so much, David, for the time today, for sharing all the details about this very promising technology. It really sounds like a great idea. And I really, really hope it can make an impact on reducing emissions and also helping airlines save money so that we can also continue enjoying affordable flights thanks to these improvements.
Exactly.
So, yeah. Yes, I'll be sharing also some of these articles and technical details on the show notes for sure. Thank you so much, David. I hope we'll coincide again in some other event somewhere in the world soon.
I appreciate it. Let me close with this. As aviation moves towards sustainability, there's three primary areas they're looking at: sustainable aviation fuel, hydrogen aircraft, and electric aircraft. Those are the top three that you hear for sustainability. Of course, they're all interested and they're all billions of dollars are being spent on that. All of those are at least a decade, in some cases 2 decades away from wide scale utilization. We need to have some solutions that give us short term, within the next 5 years, opportunities to change the face of aviation. And I think electric taxi is probably the lowest hanging fruit that can be done within 5 years that's out there between all the various solutions. But that's my opinion, but that's what I'll close with, is that idea.
Perfect. Thank you so much, David. See you soon.
Thank you.
If you like this podcast, you can support us by giving it a great rating on Apple, Spotify, or whichever platform you get it from. And remember, you can, of course, subscribe to it. And you can also get regular updates through the Allplane website. That's Allplane.tv. We have a newsletter where we cover the aviation industry every week with a special focus on innovation and sustainability. So give it a go. Thank you and goodbye.